When you picture the vast expanse of the Kuiper Belt, you might imagine countless icy worlds quietly orbiting in the shadows of our solar system. But what if I told you there's one celestial object out there that completely breaks the mold? Meet HAUMEA, a dwarf planet so bizarre, so unconventional, that it feels like it belongs in the pages of science fiction. With its elongated, football-like shape, rapid spin, shimmering icy surface, and even a mysterious ring system, HAUMEA challenges everything we thought we knew about the cosmos. In this video, we're diving headfirst into the strange and captivating world of HAUMEA. From its moons and its unique surface to the incredible speed at which it spins, and even the fascinating stories of its discovery, get ready to uncover why HAUMEA stands out as perhaps the strangest dwarf planet of them all. Stick around, because by the end of this journey, you'll see the Kuiper Belt and the universe in a whole new light. Now turning to the discovery of HAUMEA, its story begins in the year 2004, when two teams of astronomers, one from Spain and the other from the United States, both announced that they had identified a peculiar object in the Kuiper Belt. At first glance, it seemed like a routine announcement about yet another icy world at the edge of our solar system, but things quickly took a dramatic turn. Both teams claimed to have discovered HAUMEA independently, and disagreements over who should be credited sparked a heated debate within the scientific community. Imagine the intensity of the situation, years of work, observations, and research all coming down to a question of priority. The Spanish team, led by José Luis Ortiz Morno, argued that they had first observed the object using telescopes in Spain. Meanwhile, the American team, led by Mike Brown at the California Institute of Technology, asserted that their data and analysis were more detailed and comprehensive, making their claim to the discovery more robust. The situation became so contentious that it was eventually reviewed by the International Astronomical Union, the organization responsible for naming and classifying celestial objects. After careful consideration, the International Astronomical Union decided in favor of the American team, naming the object HAUMEA and recognizing Mike Brown's team as its official discoverers. However, the controversy left a lasting mark on the world of astronomy, serving as a reminder of both the thrill and tension involved in unveiling the secrets of the universe. But this is just the beginning of HAUMEA's story, because what truly sets this dwarf planet apart is far beyond its discovery. Moving forward, let's uncover one of HAUMEA's most extraordinary features, its peculiar shape. Unlike the nearly spherical forms of other dwarf planets like Pluto or Ceres, HAUMEA stands out with its elongated, football-like appearance. This isn't just a cosmetic oddity. It's a direct consequence of HAUMEA's incredible rotational speed. You see, HAUMEA completes one full spin on its axis in less than 4 hours, making it one of the fastest spinning large objects in our solar system. This rapid rotation generates immense centrifugal forces, stretching HAUMEA outward along its equator and giving it that unique, elongated form. Picture this. It's as if you took a ball of clay and spun it rapidly on a pottery wheel. The faster you spin, the more the clay flattens and stretches. HAUMEA's shape is not just an unusual feature. It's a testament to the dynamic and extreme conditions that can exist in the distant reaches of our solar system. Its elongated figure sets it apart from the smooth, rounded symmetry we usually associate with celestial bodies, providing a striking visual contrast to the more familiar shapes of its neighbors. But HAUMEA's rapid spin doesn't just influence its shape. It also plays a critical role in some of the other fascinating features we'll explore next. Now turning to yet another awe-inspiring feature of HAUMEA, let's explore its mysterious ring system. Discovered in 2017, these rings are a groundbreaking find, as HAUMEA is the only known dwarf planet in our solar system to possess such a feature. The revelation of these rings came as a surprise to astronomers during an observation of HAUMEA passing in front of a distant star, an event known as an occultation. By closely analyzing the way the starlight dimmed before and after HAUMEA's passage, scientists detected the unmistakable signature of a ring encircling the dwarf planet. This discovery not only set HAUMEA apart, but also reshaped our understanding of what is possible for small celestial bodies in the outer solar system. The formation of these rings remains a topic of active scientific curiosity. One leading theory suggests that they could be the remnants of a collision event, where debris from such an impact eventually coalesced into a stable ring structure due to HAUMEA's gravity. Another possibility is that the rings could have formed through gravitational interactions with HAUMEA's moons or other objects in its vicinity. What's even more fascinating is how these rings interact with HAUMEA's rapid rotation and elongated shape, creating a dynamic system that challenges and expands our models of planetary science. The presence of this ring system adds another layer of intrigue to HAUMEA's already unique profile, making it a standout world in the far reaches of the Kuiper Belt. So, as we delve deeper, let's uncover even more about the remarkable moons that accompany this one-of-a-kind dwarf planet. Now turning to yet another fascinating aspect of HAUMEA, let's spotlight its two remarkable moons, Hiʻiaka and Namaka. These celestial companions are named after figures from Hawaiian mythology, reflecting the rich cultural connection to HAUMEA, which itself is named after the Hawaiian goddess of fertility and childbirth. Hiʻiaka, the larger of the two moons, orbits farther from HAUMEA and is known for its bright, icy surface, which scientists believe is made predominantly of water ice. Namaka, the smaller and closer moon, has a more irregular orbit, adding to the complexity of this intriguing system. Both moons were discovered in the early 2000s, shortly after HAUMEA was identified, using powerful telescopes that captured their faint signatures in the sky. Their existence not only adds to the uniqueness of HAUMEA, but also provides critical clues about its history. One leading theory suggests that both Hiʻiaka and Namaka were formed from material ejected during a massive collision in HAUMEA's distant past. This event would have flung debris into space, some of which coalesced under gravitational forces to form these moons. What's even more fascinating is the intricate gravitational dance between HAUMEA and its moons, a phenomenon known as a barycenter system. In this system, HAUMEA and its moons orbit a shared center of mass, creating a dynamic relationship that challenges our understanding of celestial mechanics. By studying these moons and their interactions with HAUMEA, scientists gain valuable insights into not only the dwarf planet's formation and evolution, but also the broader processes that shape the outer solar system. These moons, like HAUMEA itself, are not just astronomical objects but keys to unlocking the mysteries of our cosmic neighborhood. As we unravel more about HAUMEA's moons, it becomes clear that their story is deeply intertwined with the dwarf planet's own extraordinary journey through the Kuiper Belt. So next, let's focus our attention on what makes HAUMEA stand out even further: its rapid rotation, a characteristic that defines much of its unusual nature. Moving forward, let's explore one of HAUMEA's most defining characteristics: its astonishingly rapid rotation. HAUMEA spins so quickly that it completes a full rotation on its axis in under 4 hours. To put that into perspective, this is one of the fastest spin rates observed for any large body in our solar system. Scientists believe this extreme rotation likely stems from a colossal collision that occurred billions of years ago. Such a violent event would have imparted a tremendous amount of angular momentum, setting HAUMEA on this perpetual fast spin. This rapid rotation is not just a quirky feature, it is a key factor behind HAUMEA's elongated, football-like shape. Unlike most celestial bodies, which are more spherical due to the force of gravity, HAUMEA's fast spin causes it to stretch outward along its equator. This dramatic distortion is a direct result of the centrifugal force generated by its rotation. But HAUMEA's rapid spin doesn't only affect its shape, it also contributes to some of its unique surface properties. For instance, the dwarf planet's icy crust shows signs of having crystalline water ice, a feature that might be linked to the heat generated by internal friction as it spins. This level of rapid rotation, combined with its peculiar shape and icy surface, makes Haumea a true standout among the dwarf planets. When compared to other similar-sized objects in the Kuiper Belt, Haumea's spin rate is truly extraordinary and leads to fascinating differences in its physical characteristics. Such insights not only deepen our understanding of Haumea itself, but also provide valuable clues about the effects of extreme rotation on celestial bodies. As we continue this journey through the mysteries of Haumea, let's shift our focus to its unique collisional family, a group of objects that share a special connection with this enigmatic dwarf planet. Now turning to Haumea's fascinating collisional family, we uncover yet another layer of this dwarf planet's mysterious past. This family is a group of celestial objects that share striking similarities in their surface composition and orbits, leading scientists to believe they all originated from Haumea itself. These objects are thought to be fragments ejected from a cataclysmic collision that Haumea endured billions of years ago. Such an impact would have been powerful enough to tear material away from Haumea, scattering it across the Kuiper Belt and leaving behind a trail of icy remnants. What makes this collisional family so remarkable is how it provides a unique window into Haumea's violent history. By studying these fragments, scientists can piece together clues about the nature and timing of the collision, as well as the forces that shaped Haumea into what we see today. The family members share a surface composition dominated by water ice, mirroring Haumea's own icy exterior. This connection strengthens the theory that these objects are indeed fragments of Haumea, rather than unrelated neighbors in the Kuiper Belt. Furthermore, their similar orbits suggest that they were all set on their current paths by the same ancient event, reinforcing their shared origin. Understanding Haumea's collisional family not only sheds light on the dwarf planet's chaotic past, but also helps astronomers learn more about the processes that govern the formation and evolution of celestial bodies in the outer solar system. These findings remind us that every fragment, no matter how small, holds a piece of the puzzle when it comes to unraveling the mysteries of our cosmic neighborhood. With this deeper appreciation for Haumea's dynamic history, let's now shift our focus to what lies beneath its icy surface, its composition and structure, which hold even more intriguing surprises. Moving forward, let's delve into the dazzling surface of Haumea, which truly sets it apart in the Kuiper Belt. Haumea's icy exterior reflects about 70% of the sunlight that hits it, making it one of the brightest objects in this distant region of our solar system. This high albedo, or reflectivity, is a signature feature that hints at a surface dominated by water ice. What makes this even more fascinating is the presence of crystalline water ice, a form that typically requires relatively warm conditions to form or persistent radiation to sustain. This is highly unusual for an object located so far from the Sun, where temperatures plummet and solar energy is incredibly faint. Scientists believe that Haumea's rapid rotation and past collisions may play a key role in exposing and maintaining this crystalline ice on its surface, as internal heating from tidal forces or radioactive decay could have prevented the ice from completely transforming into an amorphous state. To put this into perspective, let's compare Haumea to other well-known celestial bodies like Pluto or Charon. While Pluto also has significant icy features, its surface includes a variety of materials like nitrogen and methane ice, giving it a different appearance and composition. Charon, Pluto's largest moon, has some similarities with Haumea because its surface also contains water ice, but it lacks the same level of brightness and crystalline quality. This stark contrast highlights just how unique Haumea is among its icy neighbors. Understanding Haumea's surface composition not only adds to its intrigue, but also provides essential clues about its formation, evolution, and the dynamic processes that have shaped it over billions of years. With a clearer picture of its icy exterior, it's time to explore Haumea's remarkable journey through the solar system, its orbit and location. which add yet another layer to its enigmatic story. Now turning to Haumea's orbit and location, we find even more intriguing aspects of this unique dwarf planet. Haumea travels around the Sun in a highly elliptical orbit, taking approximately 284 Earth years to complete one full journey. Nestled in the far reaches of the Kuiper Belt, this distant and icy realm lies beyond the orbit of Neptune and is home to countless small, mysterious objects. What makes Haumea's orbit particularly fascinating is how it differs from other well-known dwarf planets like Pluto and Eris. While Pluto also has an elliptical orbit, it occasionally crosses Neptune's path, bringing it closer to the Sun than Neptune for short periods. In contrast, Haumea's orbit keeps it consistently beyond Neptune's reach, making it more isolated. Eris, on the other hand, orbits even farther out, but its path is less tilted relative to the plane of the solar system compared to Haumea's inclined orbit. This orbital tilt adds complexity to Haumea's journey as it ventures above and below the typical plane where most planets and other objects orbit. The extreme distance and isolation of Haumea mean that it experiences an environment vastly different from the inner solar system. With sunlight barely reaching these outer regions, temperatures hover near absolute zero, creating a world frozen in time. However, studying Haumea's orbit provides scientists with critical insights into the early chaotic days of the solar system. Its peculiar orbit suggests that gravitational interactions with larger planets like Neptune might have flung it into its current position, or perhaps it formed close to its present location but was shaped by massive collisions and other dynamic events. By comparing Haumea's orbit with those of Pluto, Eris, and other Kuiper Belt objects, scientists can piece together the story of how these distant worlds were sculpted by cosmic forces over billions of years. With its unusual path around the Sun casting new light on the mysteries of the Kuiper Belt, Haumea continues to challenge and expand our understanding of the outer reaches of the solar system. Moving forward, let's explore the fascinating cultural connection tied to Haumea. This extraordinary dwarf planet takes its name from Haumea, the Hawaiian goddess of fertility and childbirth, a figure celebrated for her role in creation and nurturing life. The choice of this name is no coincidence, as Haumea's unique characteristics and the mythology surrounding her resonate deeply with the planet's story. In Hawaiian lore, Haumea is a powerful and transformative deity capable of rebirth and renewal. This mirrors Haumea, the dwarf planet, which is thought to have been shaped by a massive collision in its past, scattering fragments that may have given rise to its two known moons, Hiʻiaka and Namaka. These moons are also named after divine figures in Hawaiian mythology, representing Haumea's daughters. Hiʻiaka, the goddess of dance and chant, and Namaka, the goddess of water, reflect the interconnectedness of family and the elements in Hawaiian culture. This naming isn't just poetic, it reminds us of the profound ways in which celestial objects are linked to cultural heritage and storytelling. Astronomy, while a field of rigorous science, often crosses paths with the rich tapestry of human culture, demonstrating how the cosmos inspires not only scientific inquiry but also artistic and spiritual reflection. The mythological naming of Haumea and its moons bridges the gap between science and culture, offering a more personal and human lens through which to view these distant worlds. It's a beautiful reminder that even in the face of the vast, cold expanse of space, the stories and traditions we create here on Earth have the power to travel alongside us, reaching far beyond our planet. Now turning to the scientific importance of Haumea, this enigmatic dwarf planet is not just a celestial oddity, but a key to unlocking some of the most profound mysteries of our solar system. Haumea's unusual characteristics, such as its rapid rotation and elongated shape, challenge traditional models of planetary formation and evolution. These features hint at a violent and dynamic history, likely involving massive collisions that shape not only Haumea itself, but also its surrounding environment, including its moons and collisional family. By studying HAUMEA, scientists gain valuable insights into the chaotic processes that dominated the early solar system. Its reflective, icy surface and signs of crystalline water ice also raise fascinating questions about the mechanisms that maintain such features at such an immense distance from the Sun. This makes HAUMEA a laboratory for understanding the interplay of impacts, spin dynamics, and surface evolution in icy bodies. Furthermore, HAUMEA resides in the Kuiper Belt, a region filled with icy remnants from the solar system's formation. Exploring HAUMEA provides a window into this distant frontier, offering clues about the materials and processes that existed during the solar system's infancy. Future missions to the Kuiper Belt could revolutionize our understanding of HAUMEA by providing close-up data on its composition, structure, and the intriguing ring system it uniquely possesses among dwarf planets. These potential discoveries could reshape our understanding of how planets and moons form, evolve, and interact in the far reaches of space. Hence, HAUMEA stands not just as a curiosity, but as an indispensable piece in the puzzle of unraveling our solar system's ancient and complex history. As we reach the conclusion of our journey through the wonders of HAUMEA, let's take a moment to recap what makes this dwarf planet so extraordinary. From its elongated, football-like shape driven by its rapid rotation to its unexpected ring system, HAUMEA defies the norms of celestial objects. Its two moons, Hiʻiaka and Namaka, weave a story of collisional origins, offering clues about its violent past. The icy, reflective surface adds another layer of intrigue, standing out against the vast expanse of the Kuiper Belt. And let's not forget the cultural connection, as HAUMEA carries the legacy of Hawaiian mythology, bridging the realms of science and human storytelling. Each of these features not only fascinates astronomers, but also deepens our understanding of the processes that shaped the early solar system. As we uncover these details, HAUMEA invites us to wonder, what other secrets might be hidden in the Kuiper Belt's icy depths? Could there be more worlds waiting to challenge our understanding of the cosmos? We'd love to hear your thoughts in the comments below. And if you enjoyed this exploration, don't forget to like the video, subscribe to the channel, and hit the notification bell so you never miss an exciting journey into the wonders of the universe. Thank you for watching, and until next time, keep looking up to the stars.